All right, today we are taking a deep dive into a paper that really shakes things up. We're talking about Birkeland currents, a huge concept in space physics. But according to this author, the standard model has a massive problem, and it starts with the very first line of the definition you'd find on Wikipedia.
So, think of this as a detective story. We're going to start with a really strange contradiction, then we'll investigate the official story to see where the cracks are. After that, we'll explore a potential solution and see what it means for how we picture Earth's circuits and maybe even physics itself.
Okay, let's jump right in. We're going to start with the official definition because according to the source material, this is where the puzzle begins. So here it is, pretty much the textbook definition. Sounds simple, right? You've got currents, and they're flowing along magnetic field lines. But for the author of this paper, this is an immediate, giant red flag.
This is the question at the very heart of this whole thing. I mean, wait a second. Weren't we all taught that electric currents and magnetic fields are supposed to be at right angles to each other? You know, the good old right-hand rule? This definition seems to just completely ignore that basic principle, and that's the rabbit hole we're about to go down.
So if that's the case, how on earth does mainstream science explain this? Let's follow the author's line of reasoning as he tries to pull apart the standard model and show us what he thinks are some major inconsistencies.
Okay, so the paper's first big claim is that this whole mess comes from mixing up two totally different fields, the B field and the H field. You can think of the B field as the real magnetic field, the one that actually pushes on moving charges and has to obey the right-hand rule. The H field? Well, that's more of a mathematical convenience. It's often drawn with lines that just go from north to south, almost like an electric field. And this is where the author really starts to poke holes in things. He basically argues that those classic diagrams we've all seen of Earth's magnetic field, you know, the ones that look like a big bar magnet, he says those aren't showing us the true magnetic B field at all. They're diagrams of the H field, which plays by different rules.
Now, because of this alleged mix-up, you get what the author sees as a huge contradiction. Just look at how the physics seems to change depending on where you are on the planet. Up at the poles, they say the current and field lines are parallel. But then you go to the equator, and suddenly they're using the classic perpendicular physics, the cross product, to explain things like the equatorial anomaly. So which is it? Why are there two different sets of rules?
This quote from the paper's author, Mathis, really just cuts to the chase. He's basically saying, it looks like scientists are just fudging the definitions of the fields to make the math work out, instead of having one single theory that works everywhere.
All right, so if the standard model's broken, what's the alternative? This is where things get really interesting. Let's look at the brand new model the author proposes to fix all these problems.
So, the solution is to propose a completely new and more fundamental field. He calls it the charge field. The whole idea is that the E and B fields we're so familiar with aren't the cause of everything, they're just the effects of this deeper field.
Now, this charge field isn't just a random idea. It's actually based on a concept from classical physics called Maxwell's D field. But here, it's imagined as a real physical field of moving photons. And the most important part, it's described as bipolar, which gives it what the author calls double degrees of freedom. Let's unpack what that means.
This is a great way to picture it. You know, a normal polar field, like your basic bar magnet, just has a north and a south. Two directions. But this proposed charge field is bipolar. It has four directions. It has a north-south component, but it also has an east-west component. This extra complexity, the author argues, is exactly what's needed to explain how things really work.
So what does a bipolar charge field actually do? How does it completely change our picture of the currents flowing all around our planet? Let's take a look.
Okay, so first, here's the standard picture. A current comes down from space, hits the atmosphere, and then travels sideways through something called a Pederson current. That sideways current then connects to an upward-going current, closing the loop, all above the Earth's surface.
Now, contrast that with the author's through charge model. It is completely different. Here, the down current doesn't stop and turn sideways. Nope, it goes straight through the Earth. And the up current isn't connected on the surface. It's just the other end of that flow coming out the other side. That Pederson current, it still exists, but it's just a side effect, not the main highway.
And that's the absolute game changer in this model. The Earth isn't some impenetrable bowling ball. It's more like a sponge. Charge flows right through the entire planet, creating a circuit that's fundamentally different from what's in the textbooks.
So let's zoom all the way out. If this whole charge field model holds water, what does it really mean? Well, it doesn't just challenge the circuit diagram, it challenges the very name we give these currents. And that leads the author to ask this really big question. Should we even be calling these things Birkeland currents? Are the currents we see flowing into Earth's poles actually the same thing that Christian Birkeland created in his lab more than 100 years ago?
And here's the key difference the paper points out. Real Birkeland currents, the kind you make in a plasma lab, are famous for something called a Z-pinch. That's where the current's own magnetic field gets so intense that it literally squeezes or pinches the plasma. But on Earth, the author says there's no evidence of a Z-pinch. In fact, the current and the magnetic field lines are aligned, which is the exact problem that started this whole investigation.
So, this all leads to the paper's final grand conclusion. This charge field is the real cause of everything. The things we see, like the aurora, the plasmas, the electric currents, they aren't the cause of the fields. They're just the visible effects of this much deeper fundamental charge field flowing through the Earth.
And so we're left with this one last, really mind-bending question that kind of sums up the entire paper. What if the key to understanding all these cosmic circuits isn't about studying ever more complex plasma physics, but about realizing that the most fundamental field of all has been hiding in plain sight for over 100 years?